Okay. The last thing I talked about is this law. What's this law called?
Henry law.
Henry's law. Henry's law. What's Henry's law talks about?
Solubility.
Dissolving what? Gas in liquid. Dissolving gas in liquid or in water or whatever. That's what is talking about. Henry's law talk about dissolving gas, and it says that the solubility of the gas, which makes the concentration, is related to what? Low pressure. So as you increase the pressure, what will happen to the concentration?
Increase.
Increase. And we have to know this relation. What's the unit for the C?
Mole per liter.
Yes. So it is actually what? Which unit we used?
Molarity.
Molarity. Moles per unit, per liter, which is molarity. Is it small m or big M?
Big M.
Huh?
Big M.
Big M, capital M, yes. And what's P?
Pressure.
In what?
ATM.
ATM. Or if it's given in something else, what else we can give it other than ATM?
Pascal.
Pascal, Pascal, or we can give it, what's this?
Millimeter mercury.
Mercury, millimeter, Hg they say, or what's the other name for it?
Torr.
Torr, yes. All of these you must know, and they're all related, but we use ATM, depends. And then what's K?
Boltzmann.
No, it's not Boltzmann.
Henry's
And constant.
Henry's law
Henry's
constant. That's K. Henry's law constant. Good. I hope this is clear. But let's solve this problem quickly. Calculate the concentration of carbon dioxide in soft drink when it is just opened. The pressure is 5 atmosphere when it's closed. When the bottle is closed, is carbon dioxide, the pressure is 5 atmosphere. Now, when it is open, what will be the pressure of CO2? The total, when it's open, usually the total pressure of the air is what? Usually. What's the pressure around us?
1 atmosphere.
What the 1 atmosphere? But this is the pressure of N2 plus pressure of O2 plus pressure of CO2 plus pressure of other gases. Okay, the pressure of, we take the pressure of O2, CO2 only in the air, CO2, and it is the pressure of the air, of the CO2 in the air is actually only 0.0003 atmosphere. And we care about the the pressure of CO2. What's the pressure of, what's the molarity or the concentration when it is closed? What's the concentration of CO2 when it is closed? The Henry's constant is given to you here. All right. and look at the unit. Okay, so what's the concentration of before we open it? What's the answer? It's K.
3.1.
K times P. K is given to you here. And the pressure before we open it is given here. So what's C? Give me answer right away.
It's 3.1 multiplied by 10 to the power minus 2 mole per atom liter.
Times what? It's
Times
3.
1.
The pressure before we open it is 5. And this is the Henry's constant. So what's C? Multiply this number by 5. That's it. Give me an answer.
0.155.
0.155.
0.155 more. What's the unit?
Molarity.
Mole
Mole per liter.
or capital
Okay.
is acceptable. Clear? What's the concentration after we open it? B. We want to solve B. What's the pressure or the concentration after open? What are you going to do? C equal to what? Same thing, K, which is here. What's the pressure?
Multiply by 0.0003.
0.0003 atmosphere, and you calculate it. What's the answer? Give me the
9.3.
Multiply 10 to the power minus 6.
9.3 times 10 to the minus 6.
Doctor, is this number fixed?
What?
The pressure of the CO2
Yeah.
0.0003
Uh-huh.
ثابت يعني.
Start.
اقول لك هذا الضغط حق ال CO2 ال 0.003 ثابته كل مره بنستخدم نفس الشيء.
No. It will be 0.0003 if the total atmosphere, total pressure is 1 atmosphere. The total pressure, usually the pressure around us about 1 atmosphere. It is less or more slightly. But if it is 1 atmosphere,
So it's given in the question.
yes, usually I will give you what's the pressure like this. Or I can ask you to find the pressure if I give you the concentration, things like that. But yes, it will be given to you. Okay, good. Next. When we have, don't forget, I want you to memorize the name. What's the name of the law?
Henry.
What?
Henry law.
Henry's. Henry law. Don't forget the name and don't forget the relation, which is C equal to K times P. That's the first relation that we're going to memorize in this section. Next, the second name I want you also to memorize, Raoult's law. Raoult's law. What does it say? When you have any solution, or when you have pure liquid, let's say pure water, all right, then the pressure, there will be always some vapor pressure above it, always, any liquid. And let's talk about water because we are much more interested in water. The pressure that is for pure liquid, we're going to call it P10. P10. All right? Now, when we have solution, the same liquid, but plus solute. This means we have liquid with solute. Then the vapor pressure will be lowered. So if there is here 1, 2, 3, 4, 5, 6, 7, now there is only 5 vapor pressure above it. And we're going to call this simply P1. So what's P1? Pressure of what?
Liquid plus solute.
What?
Solution.
Pressure of solution. What's P1? 0.
Yes.
Pure liquid.
Pure
The
liquid.
air.
Pressure
Yes.
of pure liquid.
Pressure, vapor pressure, vapor pressure of pure liquid. Excellent. And then, so you know this and you know this. Now I want this number. This is now called the mole fraction. Mole fraction of solvent. So, of solvent. So, what's this? X1 equal to what?
In partial over in total.
M what?
Partial of M total.
What's impartial?
For certain constant.
No.
Moles
What's
of solute.
mole fraction? We talked about it last time.
Moles of solute.
No, I said mole fraction of solvent. So it's moles of
solvent.
vent. Divide by what?
By moles of solvent plus moles of solute.
Of solvent plus what?
Moles of solute.
Moles of solute. All right? All right. I hope you know this. So this is for solvent, and that's why 1, 1, 1 for the same thing, which is for the solvent, not for the solute. When we have delta P, how much the difference is actually equal to delta P, the difference in P1 plus P with delta P, which is equal to P10 minus P1, then this is equal to X2 times P10. In this case, that's the difference between the two pressure. Delta P is this one. Then what's X2 in this case? Yes?
Divided by moles of solution plus moles of solvent.
Moles of solvent plus moles of solute. That is when we take the difference between the two. But this is the most important law, which is P1. Don't forget it. P1 equal to what? X1 times P1 naught. And we defined everything, and I want you to memorize it very well. Good. Calculate the vapor pressure of water over solution made by dissolving 225 grams of glucose in 575 grams of water at 35 degrees C. The vapor pressure at 35 degrees C of water is equal to P 42.2 millimeter Hg, millimeter Hg. So what's this? This is P0. Okay, what's required in this question? We want to calculate what?
P.
B1.
We want to
P1.
calculate P1. P1, we don't know what's P1, which is equal to what?
X1
X1 times
P1
P1 0 not. Okay, okay, go ahead, solve the question and tell me what are you going to do? Go ahead. What's the first thing you're going to do?
calculate the X.
Don't forget the mass of water, the mass of glucose is 180.2 and the mass of water is 18.02. This is the mass, molecular mass of glucose. And this is the molar mass of H2O. So what's the first thing you're going to do? Moles what? Glucose.
Mass over molar mass.
Okay, which is equal to what? 225 divided by 180.2. And you have an answer. What's the moles of water?
1.25.
This is 1.25.
The first one.
First one, 1.25. Good. Next, moles of H2O, which is 575 divided by 18.02. And give me answer.
31.91.
Are you sure?
Yes.
31.91.
91.
Good. Calculate X1. I'll put it here. X1, what does it equal to?
Mole of solution, mole of solvent.
Give me numbers.
Okay.
What should I write? 31.91 divided by what?
31 plus
31.91
1.1.
Exactly, plus 1.25. I hope your numbers are correct. I hope more than one is doing it. Okay, what's the answer?
0.96.
0. Point what?
96.
96. What's a unit?
Atmospheric pressure.
What's the unit?
Without unit.
Yes, units. Unit what?
Unitless.
Unitless, no units. Exactly. Now, what's P1 then? Very easy now. P1 equal to what? 0.96 times what?
Multiply
42.2.
What's the answer? Quickly.
40.5.
40.5
5.
what? It should be 40.6 actually. Very good. Is this easy?
0.61. I got.
A little bit.
Easy. Good. Let's go to the next question. Okay. When we have two liquids together, then the pressure, if we mix, if the solute and solvent both are actually liquid. If they are both liquid, then each one will have vapor pressure. So this is the vapor pressure of liquid 1. If I have, this is liquid and this is liquid, and this I will call liquid A and this is liquid B. Then the pressure of we will have Raoult's low for the solute. This is for the solute for maybe. And this is for the solvent. Because they are both liquids. And then if we want to have the total pressure, what will be the P total?
We add them.
We add them together, which is BA P, right? As simple as that. If they are both liquids, and that's what we are doing here. Can you see it here? So if this is B total, it's BA plus B2, and we should have it like this if we want the mole fraction, and that's the diagram that represent this two liquids. See, benzene and toluene are both liquids, and this is the pressure of toluene, and this is the pressure of benzene, and this is the mole fraction as it goes from here to here, and this is the total pressure, which is B total equal to these both two. And if this line is straight, we call these as ideal if it is straight. Usually it is shifted either down like this or up like this, and in this case it will not be ideal. If it's straight like this, then this is called ideal solution. Okay, good. Next, we're going to talk now about boiling point elevation, and I want you to memorize both of them at the same time. And even though it's another slide, I will also put it here, and I will call this boiling point elevation. What's elevation means? What's elevate?
ارتفاع أو رفع يعني مسافة.
رفع.
rise.
And freezing point depression. What's depression means?
خفض.
انخفاض.
خفض. Freezing point depression. I'll call it freezing point depression. Okay, so when the liquid water, what's the normal freezing point for liquid water?
0.
0. And this is pure liquid, pure water, H2O. What is the normal boiling point for water?
100.
100, if it's pure. What will happen if we add solution? For solution, what will happen to the freezing point?
Decrease.
It will be less than 0. What will happen to the freezing point?
Depression.
Will be, no, elevation, boiling point elevation. It will be more than 100. Then
No, I
this
mean
elevation.
freezing.
Elevation means increase. And this will be depression, which means
Decrease.
decrease. So the range will increase like this. The range, it will be more than from 0 to 100. And this is available in this diagram, and you can see it here. Now, this boiling point and freezing point are related by this equation, which is delta TB is proportional to M. What's the small m?
Molality.
What's the small m?
Molality.
Molality. Molality. What's delta TB?
Temperature.
Boiling
Point. Boiling point.
Temperature and what? What?
Boiling
point.
degree C.
The boiling point. The change in the boiling point. So for water, if the water if the solution water solution is boiling at 105, then what's delta TB in this case?
5.
5.
5 only. Why?
Because delta like the normal is 100 will
100.
because
Okay.
it's the difference between.
Exactly. And if the water freezes at okay, by the way, no, before I go to this, and this is equal to, I want you to memorize this equation very, very well, which is delta TB, change in temperature, is equal to M, which is molality, times KB. What's KB? It's called boiling point elevation, what? Constant. Good. For the freezing, we have the same law, delta T freezing equal to what? K
KF.
F. KF times M. In this case, what's M?
It is molality also.
Molality. What is delta TF?
The difference between temperature and
The
freezing
difference
point.
solution and the liquid, right?
Yes. Yes.
Okay. What's KF?
The freezing point depression constant.
Freezing point what?
Depression
Depression
constant.
constant. I want you to memorize these two laws together. Is this clear? And
Yes.
these are different. The KF and KB is different. Is this clear? Good.
Yes.
Now,
Doctor, I have a question.
just a second.
Could
These are KB. Don't memorize these numbers, but these are the KB and KF for water, for benzene, for ethanol, for acetic acid, and for cyclohexane. And these numbers, don't memorize any number of these numbers. I will give it to you in any question. I'm not going to ask you to memorize anything here. What's your question? Go ahead.
can the freezing like temperature evaluate, or just it's for the boiling point?
I did not get your question. What's your question? One more time.
Like we saying the boiling point evaluate when you add it to solution, right?
Evaluate, elevate. You mean?
Elevate, sorry.
Elevate. Yes, it will increase. Yes.
Yeah, can the like freezing point also elevate?
No, it will be always depressed.
Yeah, so that's like the boiling point is elevate and the freezing point is depressed.
Yes,
Right.
that's exactly what you're saying. Always depression
Always, okay.
and elevation. Elevate and depress. Depress means decrease, less than 0. And elevation means more than 100 for water only.
Okay.
Clear?
Yeah, clear now.
Good. Solve this problem. Ethyl alcohol, ethylene glycol, okay, is a common, do you know what's ethylene glycol? Do you know what's ethylene glycol?
No.
No.
That's what you use in your radiator in your car. Do you know the green solution that you put, or sometimes it's red? That's ethylene glycol. They add to the water ethylene glycol only. Is this clear?
Yes.
And they call it automobile antifreeze. They call it in the market antifreeze. Okay. Now, calculate the freezing point and the boiling point of solution containing 685 gram of ethylene glycol in 2075 gram of water. That's what you usually have in your car. They mix ethylene glycol with water and they give it to you, they sell it to you, and that's approximately the amount. We want to know what's the the boiling of the water and the freezing of the water because of this. We want to calculate the freezing point and the boiling point. What am I going to give you? I give you the molar mass of ethylene glycol, which is 62.07. What's the molar mass of water? Everybody knows this.
18.02.
18.02 gram per mole. Don't forget this. Okay, and this 62.07, you should calculate it from your periodic table, but it's given to you here. Is this clear? But what I'm going to give you KF and KB. This is KF for water, and this is KB for water. Clear? Now, what will be the boiling point of this solution? Go ahead. What's the first thing you're going to do?
Find the molality.
Find the molality, exactly. And the first, before you find even the molality, what's the very first thing you're going to do? Find the moles of
ethanol glycol water.
Glycol. Ethylene glycol. Okay, ethylene glycol. What's the number of moles? What are you going to do? Divide. Yes.
685
mass
by
by molar mass.
This number.
62.
Give the answer.
62.0.
11.
What?
11.03.
11.04 actually. Mole.
Yes.
Yes. Okay, mole. Good. Next, what are you going to do? How to find molality?
Moles over liter.
Which is 11.04 divided by what?
Divide by a kilogram of
Kilogram of
water.
solvent.
Yes, not liter. The person who said liter, wrong. It's not liter. We divide
It's
by
kilogram.
what? In kilogram.
Kilogram.
Should I divide by what? What's the number?
The kilogram of water, which is 2.075.
2.075. So the mass of water, I change it to kilogram, which is 2.075 kilogram. That's it. Give me answer also.
5.32.
5.32 molal ethylene glycol. Very good. Now, is this easy or difficult?
Easy one.
Very easy. So what will be now? What will be delta T freezing or boiling? It's okay. Freezing. Let's say delta T freezing. What does it equal to?
So equal to 5.32 multiplied by 1.86.
You have to multiply. Don't forget that delta TF equal to constant. Let's write the law. I want you to memorize the law first before you put number.
Constant of freezing.
Okay, freezing times
Molality.
molality, which is equal to 1.86 times 5.32. And what's the answer?
9.8. But 9.9.
9.9. Very good. I'll take 9.9. Okay, 9.9. And now this is the number we got. Now, what's the freezing of this liquid, of this solution? What's the freezing point? It will be freezing point. minus 9.9. Is this clear?
Yes.
When I calculate it,
Yes.
I have 9.9, and then I have to subtract it for, this is the difference with 0. And so the freezing point will be minus 9.9. What's delta T boiling? Again, don't forget what's the equation. K boiling times what?
molality.
Molality. And so what's the number? 0.52. I got it from here. Don't memorize this number. Times what?
5.3.
5.3.
Which is exactly like this one, the molality, same number. And then give me answer.
2.8.
2.8.
8. Oh, 76.
2.7.
Very good. 2.8. So what's the boiling point of this solution? Boiling point of solution.
Minus 2.8.
No.
No.
97.2.
No.
Yes. 100.
It will increase. It will be more than 100. It will be 102.8. So what we calculate is 2.8, which is the increase, and we will add it to 100. And
because we are talking about water.
This is water, of course. We were talking about water. This is in water, So this will be 102.8. This means it will increase by 3 points approximately. And it will decrease by minus 9.9.
Doctor?
Yes.
What is the temperature on the question? 197.
But this is boiling point of ethylene glycol. You don't need it. Boiling point of ethylene glycol, because actually it will even, this one affect the pressure slightly, but don't worry about it.
Okay.
All right. Is this clear?
Yes.
Solve this problem.
Yes.
Is it easy?
Yes.
Good. Let's go. So, last thing, osmotic pressure. Osmotic pressure. What's osmotic pressure? Osmotic pressure, we're going to represent it by the letter bi, like this. This is called osmotic pressure. Osmotic pressure, this is called osmosis. I want you to know this word because it's extremely important word, especially for Saudi Arabia. What is osmosis? Osmosis, I will give you this example and you will understand. If you have two solutions like this one is pure, and this one is solution. This means pure liquid, and let's talk about water because we are always concerned about water. This is pure water, and this is called solution. And in Saudi Arabia, this solution is seawater. What's this? Seawater. And in between them, this line here, this is called semi-permeable membrane. Semi-permeable membrane. Okay, I want you to memorize these words very, very well. This is important, extremely important word, especially in Saudi Arabia. Semi-permeable membrane. What's this semi-permeable membrane? This semi-permeable membrane allows small molecule, which is the water molecule, to go to this side, but does not allow big molecule to go to this side. And the water can go from here to here, but the big molecules like this will not go to this side. And that's what they do in Saudi Arabia. So what will happen because the water, because the vapor pressure here, vapor pressure of water of H2O is higher than the vapor pressure here, the water will go from this side to this side. To prevent it to go from this side, what we are doing, we put pressure in here. We put pressure in here. We put a lot of pressure to make the pure water to go from this side to go to this side. And this is called reverse osmosis. I want you
هي
to
نفس هالاسطوانات اللي تكون في التحلية دكتور.
هذه الاسطوانات اللي في التحلية exactly. معظم الماء اللي نشربه الآن في السعودية من this process which is called RO. ولو سألت أي واحد يشتغل في التحلية إيش معنى كلمة RO على طول حيفهم إيش تتكلم عنها أنت. أصلا أنت لو تروح للتحلية ولا if you go to desalination plant, the only thing they will talk about is RO. What's RO means?
reverse osmosis.
reverse osmosis. ايش اللي يسوون؟ يجيبون ماء البحر هنا. This is sea water. And they put a lot of pressure here, a lot of pressure. ويحطوا هنا ايش يحطوا هنا؟ ايش يحطون؟
membrane.
Semi-permeable membrane. You have to memorize the name. Semi-permeable membrane. هو من نوع من الممبرينز خاص بحيث allows only water molecule to go to this side. Only water molecule. And when you put pressure here, what will happen? The water, only pure water, will go to this side and we will send it to you for drinking. Is this clear? What's the process called?
Reverse
osmosis.
osmosis.
Which is reverse osmosis. Reverse osmosis. We want in this now to calculate this pressure. How much is this pressure? This is called osmotic pressure. Osmotic pressure. And we will represent it by this by is proportional to M. What's the big M?
molarity.
Molarity. Molarity. And by is proportional to M or equal to M times R times T. Okay, what's by?
Osmotic pressure.
Osmotic pressure. Don't forget this and memorize it. Okay, and what is M?
molarity.
M. What's M?
Molarity.
Molarity. Don't forget molarity. And of course, what's T?
Temperature.
What unit?
Kelvin.
Kelvin. Okay, and what's R?
Gas constant.
Gas constant, which is which gas constant?
8.31.
0.081. You don't have to memorize this, but the one which is with liters, and because we are going to talk about molarity, liter atmosphere divided by mole Kelvin. 0.0821. As I said, this is available for you in the periodic table, but it's better to even memorize this number. I don't mind memorizing it. Is this easy? That's also this law or this process, which is called osmotic pressure, is also used for لا سمح الله الله لا يبلانا مع في غسيل الكلى. غسيل الكلى also, that's what they are using, which is osmotic pressure, and they clean the liver, كدني الكلى هي الكدني طبعا. الكدني when they clean it لا سمح الله الله لا يبلانا معاهم فشل كلوي يستخدم الازماتيك بريشر ايديا to clean الكدني. Is this clear يا شباب؟ Very good.
Yes.
Okay. Now the three equation. Let's talk about this. Three equation. Very important equation we talked about. The freezing point. What's freezing point? What?
Depression.
Don't forget depression. And boiling point.
Elevation.
Elevation. And the last one is
Osmotic
pressure. Okay. What's the equation for freezing point depression?
Delta T equal
freezing. Delta TF. Okay. Equal to what?
KF M
times molality. Good. What's this equation?
delta T B
Delta TB
KB
KB M
B times
molality.
and what's this equation?
by equal MRT.
What M?
Molality.
M R T.
times R T.
Okay. I want you first think about this equation, read them and memorize them extremely well. Now, this equation apply for units. See, what do I mean by units? This means if I have sugar, each molecule, which is C6H12O6, it will be 1 unit. 1 unit. But if we have NaCl, when you dissolve it in water, it will give you Na plus and Cl minus. So
That's 2 units.
this will be 2 units. Okay, if we have something like calcium fluoride, it will be calcium 2 plus and not plus. I will use and 2 if minus. So how many units will be this?
3.
3 units. Don't forget this. Okay, these are each unit is affecting this equation. That's why in these 3 equations I will add another thing, which is I and I. What's this I? This I will call, I'll give you the name later for it. It's very important. But this is I calculated and I actual. What do I mean by I calculated and I actual? I will tell you, like for example, if I have sugar, what is I calculated? 1, because I said it's 1 unit. And what is it going to be actually? Also 1, because it's 1 unit. Let's talk about NaCl. I calculated, we calculated here. How many units is this?
2.
2. But Are we going to see it too? Usually, maybe it will be very close to 2, but usually we find it is less than 2. Why is that?
Why?
Give me a reason why you think it's the calculated. I wrote here calculated. We calculated as 2. Everybody said it's 2 units, but actual it will be less than 2. Tell me why. Because maybe not all NaCl will go to Na plus and Cl minus. Maybe some will stay as NaCl, and not each one will give you 2 units. This one will give you 2 units, but if NaCl stay in solution as NaCl, then what will happen? 1 unit will give you 1 unit. Is this clear? So usually it will be less than 2. Okay, how about for CaF2? What will be the calculated value?
3.
3. But what are you going to see?
Less than 3.
Less than 3. Are you going to see greater than 3?
Impossible.
Impossible to see more than 3, but it's very possible to be less than 3. Is it possible to have exactly 2 or 3 here? Is it possible?
Yes.
Yes. The maximum is 3, but it should be less than 3. Okay, let's have
what
something else.
is the reason that make NaCl do not dissolve? I mean,
It stays as it is. NaCl,
Yeah.
bad example. NaCl will 100% dissolve, but there are some other things like CaF2. Not all of it will dissolve. Okay.
but there is a reason. Is there is a reason?
Aluminum trifluoride. How many you think I calculated? What will be the I calculated for AlF3?
Al
4
4. Why?
plus 3 minus 1.
Plus 3 and minus 1 times 3 is 4 units. And what will be the actual?
less than 3, less than 4.
Less than 4. Maybe equal to 4. Can it be more than 4?
No.
Never. Is this clear? This was calculated, the I actual was calculated by scientists. The name of the scientist, listen here, actual. Calculate actual. This is in the lab. In lab, we calculate. This is calculated what you do yourself. I mean, from the iron. This I, which is actual, which is known, it is done by a scientist. I want you to memorize the name of the scientist. What's the name of the scientist? Van 't Hoff. Van 't Hoff factor. And we have it I. Okay? Don't forget this. Are the 3 equations now, which we talked about. What's the name of the first equation?
Boiling point.
Boiling point.
elevation.
Point elevation.
Elevation.
And what's this equation?
Freezing point.
Depression.
Depression. And the last equation?
Stomach.
Osmotic pressure.
Osmotic pressure. Don't forget these names, very important. Okay, what's delta TB? The difference between what?
Between the boiling point of solution and the boiling point of liquid.
Of the solvent.
Of the solvent, yes.
Yeah, you have to use the word solvent. Very good. Okay,
Yes.
what's I?
The number of units.
What's the name? I want you to memorize the name.
Van Hoff.
Van 't Hoff. Hoff. You have to memorize the name. Van 't Hoff. Van 't Hoff factor. What's KB?
Boiling point elevation constant.
Constant, exactly. What's M?
molality.
Molality, yes. Okay, very quickly, what's delta TF? Difference.
Difference between
Point. What's I? Van 't Hoff. Van 't Hoff factor. What's KF? Yes.
Freezing point constant.
Point depression constant. Right? And M is molality again. Very good. Last thing, what's by?
Osmotic pressure.
Osmotic pressure. The same thing here. Very good. What's I?
Van 't Hoff.
Van 't Hoff factor. What's M?
molarity.
Molarity. Don't forget this. And what's R?
Gas constant.
Which is what?
0.0821.
Yes. As I said, you don't have to memorize this number. It's available in the periodic table, but really memorize it and keep it in your mind. It's available. If you forget it, you can go back to the periodic table very easily. Okay, the last question is what's T?
Temperature in Kelvin.
Temperature in Kelvin. Kelvin, yes. Very good. Let's solve this problem then. Very good. And as I said, this is I calculated and I measured or actual. See, and if it's 1, it's always 1, same. But if it's 2, usually 1.9. And in ACL2, it's 1.9. Look at MG is 04. How many you should have? How many units you should have? Actually, I mean calculated, 2. But what's the actual? 1.3, less than 2. MgCl2, how many you should have? 3, but actual 2.7. If ECl3, we should have 4, but actually have less than 4, which is 3.3. Is this easy? As I said, this you should know how to calculate. How to find this one.
the calculation. We use the calculated one. Yes.
Yeah. If I ask you to put the calculated, you should know it. It's this one. But
Yeah.
this feature, you don't have to memorize it. Actually, it changes depending on the concentration. So it can change from one solution, from even for an ACL or anything. So don't memorize this number. This number, don't calculate them. But this one, you should know them once I give you anything. Like, for example, if I give you, it's not written here, but if I put ALF3 in here, what are you going to say here? What I can? 4. Yes, you should know this. How about measured?
3.
Less than 4.
Yes, it should be less than or equal. It could be equal to 4, but it should be very close to 4 or less than 4, but I don't know what is it. Okay, if I give you, for example, let me say CA2, CA3 N2, anything. I mean, no, that's not a good example. Let me give you something else. Yes. Let's assume that I have this thing. What should be the calculated?
Five.
Yes, say it loudly. Why are you afraid?
5.
Yeah, because we have 3 of this and 2 of this. The total is 5. But how much we are going to see in this side?
Equal or less.
Or equal to 5, but it will never be more than 5. I know this, but I don't know what is it exactly. maybe it's to 1.9, 2.5, 4.7, 4.8, anything, I don't know. But this one calculated, I know it is 5. Is this clear? Easy.
Yes, it's easy.
Okay, osmotic pressure is of 0.100 molar potassium iodide solution at 25 degrees C is 0.465 atmosphere. Determine the experimental Van't Hoff factor for Ki. Go ahead, solve this problem. What are you going to do?
Pi equal IMRT.
First, the equation that I'm going to use is pi equal to what?
I
M
RT.
T. Okay. And before I even start the problem, what is it? What is required in this question? What am I going to look for?
molarity and temperature.
No. What is the? Read the question and tell me what are we looking for?
I.
For I, actually, for looking for I experiment in the lab. That's what we're looking for. Before I even do the problem, what is I calculated for this compound?
2.
2
Yes, why are you saying 2? It is 2, but why?
+1 and -1.
Yes, that's 2. So what is my answer should be before I do even the problem?
Less than or equal
Less
to.
than or
Than or equal to 2. That's exactly what's happening. Good. Let's solve the problem now. So I'm going to calculate I. What is, okay, give me, what should I put under this one? What's pi then in this case?
0.465.
Okay, equal to I, which I don't know, times what?
0.01 molarity.
0.0100 times what?
Times 288. 208.
What's
Oh, yes, the constant. Yes, 0.0821.
times?
298.
Which is 25 plus 273.15. You must memorize the number 273. This you must memorize 273.5.
Yes.
Okay. Use your calculator. Calculate what's I.
$1.89.
Which is 1.9.
Very
good. Before I tell you if it's correct or not, is this possible answer?
Yes.
Yes,
Yes,
less than
possible.
2.
Why?
Because
Less
it's
than 2.
less than
Less than 2, very close.
and
to
very close to 2.
Yeah, fine. It's very close. If somebody gave me 1.6, is this possible answer? It is possible.
Yes.
But
Yes.
Unlikely.
1.
Possible.
No, impossible.
Impossible.
This is impossible. But this one possible. It depends on the concentration, actually.
Yes.
Is this clear? Very good. How easy is this thing? Very easy, I hope. Okay, good. Now, now something else. Okay. Quinone, let's solve this problem. Quinine was the first drug widely used to treat malaria. طبعا كلنا نعرف الملاريا صح؟ مرض الملاريا.
معروف.
معروف. I hope so. Everybody knows malaria. This is the medicine that they use. It's called quinine. Okay, and it remains the treatment for choice for many years and still now. A solution prepared by dissolving 10 grams in quinine in 50 milliliter of ethanol. The freezing point 1.55 below the pure that of pure ethanol. So what's given to you here? What's this 1.55?
Freezing point.
Freezing point, it is below, this means below the pure ethanol. Then this is actually delta T already given to you. Delta T freezing, which is equal to what?
KF times molality.
I times, don't forget I.
Yes, I times KF times molality.
Times Kf times molality. Okay, this one is organic compound. Organic compound, when you put it in water, does it dissociate? Like sugar. Hello? If you put sugar in water, is it going to dissociate? It will be sugar, 1 unit.
So the I should be 1.
Why? I what is what?
1.
1. And quinone does not dissociate. So quinine will stay as quinine. So what's I? Also 1. So now I want to, so I is already 1. What's delta TF?
$1.55.
It's already given to you. What's KF? Let's see, what is KF? Is it given to you? This is ethanol. It must be given. Let's go back to this table. Okay, this is ethanol. That's KF. Write it. Oh, this is KB. So KF is what?
1.
Don't forget it. 1.99. I'll go back. As I said, this will be given to you. I don't know. So we are here back. So, okay. So 1. Yes. So what's KF?
1.99.
99. Okay. And what's molality? We don't know what's molality. Okay. Calculate molality. Go ahead, give me answer.
$0.77.
Let's see. Who got the same thing? 0. Anybody else? Actually, 0.7. Read your calculator one more time.
0.778.
Which is 0.78 or 779, whatever. Okay, molal. Good. Now we want to calculate. We have a solution prepared by dissolving 10 gram in 50 milliliter of ethanol. And we have molality. Can you calculate the mass of quinone? The molar mass. First, you have 10 gram, forget about the 10 gram, 50 milliliter. We want to change the 50 milliliter into gram. How can you do that?
Multiply it by the density.
Which is 0.789 gram per milliliter. Milliliter will go with milliliter, and you have the answer. Give me answer quickly.
39.5.
39.5. Are you sure?
Yes.
0.5 what? Give me more than one number.
45.
39.45. 39.545.
No, 39.45.
45. Okay, good. Let's take this. Fine, I'll take this. Okay, good. Now, this is the mass of solution. What's molality?
It is 0.7.
No, just a second. What's the mass of ethanol in this case? This is the mass of solution by dissolving 10 grams of quinone in 50 milliliter, and the total mass is 39.45. This is the mass of solution. What's the mass of ethanol?
29.45.
9.45 is mass of ethanol. Good. Then, how many moles do we have? Can you change this to kilogram? Kilogram.
Doctor,
Yes.
39.45 isn't the ethanol mass? Because in the
No.
setup down.
No, 50 milliliter of solution. 50 milliliter of solution, and it's ethanol has a freezing point below that. Yeah, this is the solution. Okay, so the mass of ethanol only is 29.45 because I took the 10 grams of the quinone. So the mass of ethanol is 0.02945 kilogram. All right. In this case, what is the the number of moles? The molality, which is equal to 0.78 or 78, okay, mole per kilogram of solvent. So how many moles we have here? Just the moles equal to 0.78 times 0.02945. And this will give you the number of moles. Give me answer. Yes?
0.0229.
0.0229?
Yes, I got this.
No, it should be different. Oh. Just a second. Oh, yes. He did not subtract like this. Oh, yes. Yes, actually, yes. I made a mistake. Or actually, I don't like the question, but it says here that they use the mass of solution as not the mass of solution. This is the mass of ethanol only. So the 39, so I don't have to do this. It's a mistake. It's a bad question. This is the mass of ethanol. Mass of ethanol. So actually, this thing is by 0.039, and that's a stupid question. They should not say it this way, because it says here.
دكتور.
Yes.
How we got the molality 0.78?
From this equation.
Which point?
Okay. So the number of moles here is actually 0.0308, and then to find the number of mole or the molar mass, you divide 10 grams of quinine, divide by the number of moles, which is 0.0308, and the answer should be 325. 325. All right, and that's it. And this is the end of chapter. By the way, this is the end of chapter 13. We finished chapter 13, and I want to tell you that this 13.7, which is total colloids, it's not required. Don't study 13.7. And also, we have all the chapters, everything, study everything except 13.7 and 7.7. I also told you not to study these two things, 13.7 and 7.7. Chapter 7, the last part of chapter 7, which is 7.7, is not required. And this is the end of the whole course. All right, I will stop here. Before I stop, I'll take the attendance. And as I said, tomorrow we're going to have the quiz in chapter 13.